Planetary atmospheres are the gaseous envelopes that surround planets, moons, and other celestial bodies in the solar system. The composition, structure, and dynamics of planetary atmospheres play a critical role in regulating the surface conditions of these bodies, including temperature, pressure, and the availability of life-sustaining resources like oxygen. Composition of planetary atmospheres. The composition of planetary atmospheres varies widely depending on factors such as the planet's distance from the Sun, its size and mass, and its geological history. For example, the atmosphere of Earth is primarily composed of nitrogen, 78%, and oxygen, 21%, with trace amounts of other gases such as argon, carbon dioxide, and neon. In contrast, the atmosphere of Mars is much thinner and is composed mainly of carbon dioxide, 95%, with traces of nitrogen and argon. The atmospheres of the gas giant planets in our solar system, such as Jupiter, Saturn, Uranus, and Neptune, are mostly composed of hydrogen and helium, with trace amounts of methane, ammonia, and other gases. These planets have thick atmospheres that extend far out into space, with strong winds and storms that create distinctive cloud patterns. Structure of planetary atmospheres. The structure of planetary atmospheres is determined by the balance between gravity, which pulls gas molecules toward the planet's surface, and atmospheric pressure, which pushes the molecules outward. The structure of a planetary atmosphere can be divided into layers, each with distinct temperature and pressure profiles. For example, the Earth's atmosphere can be divided into several layers, including the troposphere, stratosphere, mesosphere, and thermosphere. The troposphere is the lowest layer and is where most weather occurs, while the stratosphere contains the ozone layer, which absorbs harmful ultraviolet radiation from the Sun. Dynamics of planetary atmospheres. The dynamics of planetary atmospheres are driven by a variety of factors, including temperature gradients, solar radiation, and atmospheric composition. Atmospheric motion can occur in the form of winds, currents, and storms, which can transport heat, moisture, and other gases around a planet or moon. For example, the atmospheric circulation on Earth is driven by differences in temperature and pressure between the equator and the poles. This creates a series of large-scale atmospheric cells, known as Hadley cells, which transport warm air from the equator to the poles and cold air back toward the equator. Weather and climate of planetary atmospheres. The weather and climate of planetary atmospheres are determined by a complex interplay between atmospheric dynamics, radiation from the Sun, and the planet's geology and geography. Weather refers to short-term variations in atmospheric conditions, such as changes in temperature, pressure, and wind patterns, while climate refers to the long-term patterns of atmospheric conditions. For example, on Earth, weather can include phenomena such as thunderstorms, hurricanes, and tornadoes, while climate is determined by factors such as the amount of solar radiation reaching the planet's surface, the greenhouse gas composition of the atmosphere, and the circulation patterns of the oceans and atmosphere. In conclusion, planetary atmospheres are a critical component of our solar system, regulating the surface conditions of planets and moons and influencing the potential for life to exist. Understanding the composition, structure, and dynamics of planetary atmospheres is an important area of research for planetary scientists, and can provide insights into the formation and evolution of the solar system as a whole.